I am going to talk about the new version of Wolfram Language and Mathematica, which we released today, version 11.3. And I really just want to have some fun playing with it because that's always great once we've released a product to actually try using it. Hopefully I won't find any bugs. We'll see. People are very welcome to ask questions and so on. This is being streamed on 3 different networks and the questions are being aggregated and I should see them fairly quickly. All right, let's get started. So let's see. Let's just check I'm running the correct version. Yes, 11.3. There we go. Cooked just a day ago here. All right, so what's new? Well, all kinds of stuff. There's we can kind of get some. I wrote a blog post, came out today about 11.3, and it has a little word cloud here that shows kind of some of the highlighted functions that are new in 11.3. But I'll go through a bunch of these. Always hard to know quite where to start. We can also get a summary by looking in the help system, not that help system, this help system, and look at the bottom here where it says new features, and there'll be a big long list of new features in 11.3. All right, well, where should we start? Maybe we can start, machine learning remains topical, and we've been very energetically pursuing all sorts of things in machine learning. Maybe we'll start there. So one of the things we've been doing is to build a neural net repository. That's a collection of interesting neural nets. We add to this every week. There's all kinds of different things that all kinds of different neural nets come out. The idea is to have them all in the format that can immediately be computed with. So let's just pick this random one. I don't know what this one does, but let's, okay, let's see. We seem to have to feed it 2 kinds of things. Actually, this looks like, all right, so let's see how this works. So I just click net model there. I can read it in here. Now it will download that net model from the cloud. And now this is a particular neural net. And there you can see the structure of the neural net. Something new in 11.3 are these nice little graphics of neural nets, and we can drill down and look at the details of them if we want to. We can go ahead and start, well, we could actually, let's just try running it. Well, I can just try the example that was there. So, contains the copied, okay. I see. So those examples are too big to get with just copying from a web page. All right. Well, then let's use let's get our own pictures here. So let's say picture of, I don't know what, Washington Monument. How about that? See whether we can get that. And hopefully, Washington Monument, historic site, image. Okay, there we go. And let's say, let us ask for, let's get some picture. How about something like Van Gogh Sunflowers? See whether that, oops. Oh my gosh, there's a type of, it appears that there's a type of sunflower called a Van Gogh sunflower. It's kind of funny, actually. Van Gogh painting, sunflowers. Let's see whether that, is that a painting by Van Gogh? Maybe we won't understand this. No, we didn't. All right, let's just try. How about we just try, let's try Monet. And let's, I just want to get a random, a random notable artwork here so I can, oh gosh, there's lots of them. So let's just get, let's get the first 5 of those. And then let's say entity value that, comma image, and eventually we're going to get a picture here, a painting. Okay, let's do that. Let's see how many of them we have. Oh, we have all of them. All right. Well, there's a nice impressionist type painting. All right. Let's close this up. Let's go back up here, and let's now take this. And actually, something which was new in 11.2 was the image restyle function. So we could actually see how that works. Just running that there. Could do image restyle on this. Oops, the image restyle on this, and we could say restyle that picture according to this. This is oh, there we go. So that was a nice fast restyling, not very high resolution. We could let's, if we wanted to, let's try running this network, which has a content and a style. So there we go, and let's say we have something that says content, and then we'd say the Washington Monument picture, and then we would say style, and then we'd say this, and that will then run this raw network that I just got from the neural net repository. At least if I could get the syntax right, there we go. It'll just run this raw neural net on that particular pair of images. Now, if we wanted to, just for fun, let's see what happens if we just take this network and we just do a net take of that, comma, let's say 10. So that can, okay. Let's want to go layers 7 through 10. So that can work. I see. Okay, fair enough. This is, I think that this net model, I think this network is a graph. And so it might be a little bit trickier to chop out pieces of that graph. I would have to go in here. Let's take a look here. And I would have to go and figure out, okay, so that's called decoder. And I would say I would go from, yeah, it's a little tricky. So I'd have to go in here. Okay, that's the internal structure of this network. It's interesting to see that here. What is that? That's a replication layer, okay. So I wonder what happens if I would try and say net take v underscore norm underscore 2. See what that does. I don't know whether this will work, but let's say that will be the name of a layer. See whether I can just take that out. No, it won't let me do that. What I wanted to do was to just put a tap in this neural net at that position and take a look at what this is doing there. But looks like I'm not going to be in luck doing that. But it's kind of interesting to see. Maybe we can try a simpler neural net. There's all kinds of things here. So one of the things that's happened with these neural nets is that, oh, look, there's even things that are specific. Okay, this is an apple to orange translation network. We could probably try running the apple to orange network on, let's see, there's the apple to orange network. Now we can pull it in here. Okay, it's taking a while to download that train network. Okay, there it is. Okay, so now this network, we could just go ahead and run that on an image. So we could rather bizarrely run that on, for example, let's try running it on this image here. And okay, don't know exactly what it did to that image. Maybe we should try picking up the image that came from, let's try picking up this actual image here that had the oranges in it. This is, you see, what happens is, because let's try doing this. Let's try doing that, and then let's try running the apple to orange network on something which is already an apple. See what it does. And then maybe what we can do here. Oh, that's really weird. That's even more apple than apples. Wow, that's interesting. Now I'm really curious what happens. Okay, we have to do this. Let us do a nest list, just applying that same network multiple times to that image of these red apples. So let's go ahead and apply it five successive times. This may be a horrible mistake, but let's see what it does. Oh, wow. Okay. So apparently those are progressively more appley apples. If we wanted to, we could probably see what happens to this network if we just look partway through the execution of that network. But let's not do that right now. Let's pick another kind of thing. So another big thing that's new in 11.3 is a lot of new functions for facial By the way, I could talk about some things, and maybe people are interested. I'll talk about some things that are new in detailed handling of neural nets. A lot of things, particularly to do with recurrent neural nets and sequence things to do with sequences in neural nets. Some fairly technical things about net state objects and so on that are relevant for neural nets that progressively learn from new input and so on. Maybe actually, while we're talking about just general machine learning, let me show you a function. We've had feature space plot in 2D. We now have a feature space plot 3D. So, for example, if I were to take, I don't know, letters of the alphabet, for example, and take images of all the letters of the alphabet, okay, I could take those and I could say make a 3D feature space plot of all those letters and see which letters are closest in this 3D feature space. So what we're seeing here is, okay, in 3D feature space, V and Y always seem to be pretty close. What are those ones up there? As we rotate around, we'll see different things here. R and C are fairly close, but we can see these in 3D feature space, and we could do that. Actually, here's a good example of something we can do. Let's get 50 random colors, and let's try putting those. Let's put those in 2D feature space. And now that will try to arrange things in some kind of color triangle. But what I'm curious about is if we do 3D feature space, will this rediscover RGB color? So that's line 21. Let's see. So this is this. Oh, interesting. Okay. So this is now. It's sort of rediscovering some things over there. In okay, there are the reds, there are the yellows, greens, etc. So actually, if we were to try, let's just try for example, let's see how this did in terms of actually laying this out. Chromaticity plot 3D. Okay, let's see how this did in terms of actually laying out the things on line 21. This would be the actual plot in 3D color space. And it's hard to tell what the correspondence is between these things. Okay, well, let me here just I'll save this because we can actually look at it. I could actually, why don't I do this while we're at it? Let me go ahead and save this out to 11.3-01. Okay, I'm going to show you something interesting that we can now do. So I can take this and it's a slightly big notebook, but let me go ahead and just cloud publish this notebook, and let me call it. Let me cloud publish it as. Well, actually, I just cloud publish the evaluation notebook, the current notebook, and let's call it 11.3-01. Okay, I'm living dangerously because I'm not quite sure what this is going to do, but let's give it a try. So what this should do is to go ahead and publish this quite big notebook out to the Wolfram Cloud. Okay, there we go. So now it made a cloud object, and that should be a public cloud object that anybody can pick up, actually. Let me see what happens if I go there. Let me just, so that I'm really doing it as an anybody, I'm going to use an incognito window in my browser here, and I'm going to go and let's see what happens. I'm going to go there, and there's all kinds of technology that has to work in order for this to operate correctly. It may not have yet had time to cache all of the stuff that is in there, but this should steadily get all of this stuff published here. Okay, I think it'll come. All right, well, let me keep going here anyway. So let me just to show you a small example of that. Let me just take a few things here, and let me just say for those, let me make another notebook here, and let me just go ahead and cloud publish that notebook. So that will now just take the content there and publish it. And let me see here. So that's rather a it's a UUID there that it made. But okay, so now we publish this, and here we have it in the cloud, and we can probably, that's just these things didn't come out as 3D plots. That's a shame. But anyway, so that's just a web page that anybody can go to, and if you wanted to, you could open it in here. I can open it here. Up now, I have to actually sign in, and then I can open it and actually be editing it if I want to, right there in the cloud. So I'm editing my copy of this right in the cloud to do different things. So let's say here, this is just going to load in, and I can be doing all kinds of computations here, whatever I want to do. I can now be just going ahead and computing in the cloud. And by the way, big software engineering effort is that, yes, there's 11.3 now running live in the cloud as well as on the desktop. Okay, well, let's go back here. Let's see, I was on a path to show you all some other kinds of things here. Yeah, I was going to talk about face-related functions. So we have a function called find faces. So let's go ahead and find a picture. Where's a good picture? I was using some pictures from famous famous to physicists, at least. There's a thing that was called the Solvay Conference. Let's just see whether we can pull in some pictures from the Solvay Conference from around 1900, more like 1920, actually. Okay, so here's a random sample picture. Let's see what we can get here. There's one. Let's take that picture, and let's see what happens if we say find faces on that picture. And let's see. Okay, so those are rectangles for the faces. And if I look up some documentation, oops, I'm using, let me go back to the page I was using before, because I had a notebook where I had everything nice and magnified. Let's go back to that one. Okay, let's use this magnified one. Okay, here we go. So now, when in doubt, of course, look at the documentation. So let me go ahead and do that. So here, I want to actually find images there. So let me say find faces, comma, image here. And what that should do, okay, there we go. So that picked up a bunch of faces there, picked out from that image. Now, what I could do also is to take that image and make a data set of what it knows about those faces. Oh, no, that's not what I want. What do I want here? I probably want to just say facial features, and then I want to say data set. What am I doing? I don't know what I'm doing. Let's see what happens if I just do this. This is now going to, so the way things like facial features work is they're using an underlying neural net. We can probably find the neural net that's actually using in the neural net repository. Okay, here we go. And now let's make that into a data set. And we will find various faces here. Boy, I don't know whether those ages are correct. They seem like they're roughly correct, at least. But that's the kind of thing we can easily do here. So, for example, if we say let's try, just for fun, I'm curious, I'm going to go one of these very self-oriented things. Let's go find my own scrapbook, and let's pick out Let's pick out a random picture. Here, there's a picture. Now, I'm curious how old I was in that picture. It says 1964 there. I wonder if it's actually true. Let's see. Let me try. The question is, which do I trust? Okay, so let's try facial features, and let's see. Maybe it'll pick up the face of the guinea pig instead. That is very unconvincing. Look at that. Okay, well, that's definitely wrong. Well, don't always trust a neural net. Okay, happy to see the guinea pig, but definitely the wrong age. So it goes. Let's try one more. Let's try something like, let's try my old, I see this is way too small, too few bits there. Let's try, yeah, there we go. Maybe that will be big enough. Let's try my 1979 student and faculty IDs from Caltech. Let's see whether it can. Now those must have been spaced by about a year. So let's see. Let's see what it does on those two. So they can find the faces. Oh, that's not bad. It's not right, but it's oh wow. It thought that was a face of age 39. That's kind of crazy. But well, that's off by a couple of years there. It thought I was older than it thinks I was older than I actually was. So it goes. Okay, let's go back here. Someone is asking, is find faces a totally new function 11.3 or did it exist previously? There was a find faces, but it did not work using modern neural net techniques, and it certainly wasn't as powerful as the one we have here. Okay, well that's one kind of thing. Let's go. How about we go to a completely different? Actually, I'll tell you what. Let's show Geo Smooth histogram. I'm just going to show some visualization features. So let's go pick up some data, some geo-related data. How about we go and look for? How about we go to our data repository, and let's look for geography. Let's see whether there's a nice. Okay, how about this? Let's go solid waste landfill facilities. That's a good obscure thing. All right, let's pull in the okay, so let's pull this in. So this will now be pulling this in from our data repository. We're loading in a bunch of data that hopefully we'll be able to go look at. Okay, here we go. So this is random data. Let's take a look here. Whether we have, okay, it's got phone numbers. Come on, it's got to have coordinates. This must have coordinates. Maybe it doesn't. Well, we'll find out in a minute. Okay, well, there, at least it's got cities. That's a good start. All right, so let's pick out, these are landfills, apparently. And let's go ahead and say, line 36, let's say we want to pick out, for all of those, I want the city entity. And that will pick out all the cities there. Let's pick, there's 6,000 of those, but let's just pick, let's just start off by saying random sample of, let's say, 300 of those. Yeah, let's say 500. And let's see what happens if we just say, we might just be able to say Geo Smooth histogram of this. Right, what was it called? Geo, I think that's right. Yeah. It's a little weird that it wasn't auto-completing there. Very strange, actually. All right, let's see what happens if I just do this. So now I'm just feeding it those 500 cities. So it's going to have to figure out where all those cities are. And then what it's going to try to do is to show us kind of a density map of these cities. Okay. While it's doing that, actually, I don't know how long it's going to take. I think it may be taking a while to find the locations of all those cities. But let's go ahead and okay, we'll have it go think about that for a moment. Meanwhile, let me just show you. Let's go look at. Let's see here. let's look in the neural net repository just for fun. Let's go find the actual neural net that deals with face-related things. So, predict a person's age from an image of their face. So that's probably the network that it's using for that computation. We can, this is kind of interesting. You can say, we can just take that network. This is of interest kind of to neural net aficionados. You can take that network that exists in Wolfram Language and you can just export it raw to something like MXNet. Well, there's a picture of the actual graph of that network. And why is this taking so unbelievably long? Well, let's do this. Let's kill that off. That's not what I wanted. I wanted to just abort that, and let me just take from line 38. Let me just see what happens if I just say geo position of take in that is 38. Let's just take 40 of those from there. Oh, didn't like that. So let's see. If I say this, okay, this is what's taking it a while. Oh, there we go. Okay, so a few of those, I see. A few of those, it wasn't even able to find locations. But let's just delete missing. Oh, that's the problem. The problem is that it doesn't know. Okay, so what I should have done here is to take the things in line 38 and just say delete missing on that. And now I will have something dense. And now I can say, hopefully, geoposition of those. And doesn't like it for some reason. Let's see. Geoposition. Oh, I know what I have to do. This line 42. What was I doing here? Oh, silly me. Okay. So hopefully this will look up all these. Okay, there we go. Finally, we got the geopositions. Okay. So now let's say Geo Smooth histogram of that. And what it will do is to take that distribution of points. Okay, there we go. So that shows the density of, it's not very exciting, but it's the density of waste disposal. It must be all those, either it's the population density in New England or it's all those very eco-proper New Englanders. I'm not sure. We could take this and we could kind of divide by the population density of the US or all kinds of fun things like that if we wanted to. But there's a start for that. All right, let's go tackle a completely different area here. Let me. So I was showing a few examples of things like. Okay, somebody's asking if we can increase the size here. Why don't I go larger screen and let me go up to 150%. If we go much larger than that, it's going to be hard to get much in here. Okay, I'm going to show you something completely different. Let's go. Well, actually, I'm curious to try something here. No, I'm going to show you something completely different. Let's go really mathy. I'm going to show you something about mathematical proofs. In particular, what I want to show you, if I can pick this up here, is here we go. Let's try this. So what this is doing is it's saying, here's, we need to have let's take a look here. This is an axiom system for group theory. Okay, so it's saying for all A, B, and C, G, we haven't said what G is, of A and GBC equals, so this is an associative law. This here is, I guess this is the identity law. This is for all A. This says that G must be the group multiplication operation. A multiplied by inverse of A is the identity element. Okay, so now we're going to try and make a proof based on, we're going to try and make a proof of this statement, G of, well, this whole long statement here. We're going to try and prove that given the axioms of group theory. Okay. Let's so what that's doing, oh, that was really fast. Wow. Normally in Wolfram language, we're trying to just figure out results. We're trying to say, what is 2 plus 2? It's 4. We're not trying to say, give us a proof that 2 plus 2 is 4. In Wolfram Alpha, we have the show steps mechanism that is widely used by students, in math and chemistry and other places, where it's saying, okay, this was the result for the integral. Now show me the steps. This is kind of a much more heavy-duty version of that. So let's take a look at this. We can say something like proof. Let's see, I think it's called proof network. Is that right? It is. So let's try doing something like proof graph, for example. So this is showing. So this particular thing. Let's start off with proof data set. So the question is, why is this result true? Okay, and the answer is, here's the proof. It's 29 steps long, and it says we start off from this axiom, x1 is g of x1 e, etc., etc., etc. We're starting with this axiom, and then we're going to go through figuring out a bunch of intermediate lemmas, and eventually we're going to get the result. Okay. And for example, we can just show sort of what's the network of what depends on what in that proof. So we can go ahead and say proof graph. So that's showing us how the different lemmas in proving this come from each other. And if we wanted to, we could also say, give me a proof function, which is just a function which we can evaluate, take this whole proof function, and really it just defines a bunch of substitutions that are purely structural substitutions. If we take that function and apply it to nothing, it'll rather unexcitingly return true. And what that means is that you can have you can validate that this is a correct theorem. Somebody is asking about wishes Wolfram Alpha is open source. Well, you can get all this stuff. You just go to the web. You can just use all this stuff for free. Just go to the web. You can just go to wolfram.com. You can start. Let's see. We could go here, for example, and you just go there and go to create a new notebook. And you don't have to log in or anything. You can just start doing all this stuff. In fact, I'm going to try. I'm going to live really dangerously here, and I'm actually going to try doing the thing I just did here, which is a very new thing. But let's see whether I can actually do that right here, free on the web. So let's go there. Let's see whether this works. Let's take this and let's try it. Oh wow, that was cool. Okay, let's see if I can go and get the proof graph there. So this is just running in a you can just go to this web browser, go to a web browser, and you can just be running this stuff immediately. You don't actually even have to log in. So hopefully you find that useful. The other thing that's interesting, of course, about all this stuff is you can go. Let's see. Yeah. So asking questions about, do we have stuff to do with Bayesian statistics? We have all kinds of stuff to do with Bayesian, all kinds of things. I don't know. If I say something like, this is not new in version 3, but I could 11.3, but I'll show you something I could do. I could say, let's just look at some statistical kinds of things. So let's say we have X is distributed according to, let's say, a log normal distribution. I'm very confused by something here about this, what I'm running here, because I'm not seeing the usual. What on earth is going on? I am not. This is making it much harder for me. I'm not seeing the usual auto completions that I would see, and that's it's very peculiar to me. And okay, so anyway, let's see, how many parameters does a log normal distribution have? This is really odd. I'm going to okay, let's see, 2, 2, for example. Okay, so let's say X is distributed according to that. I could, for example, say, give me a, let's just take that log normal distribution and say, give me 100 random variates distributed according to that log normal distribution. Or let's say I make a histogram with 1,000 random variates distributed according to that log normal distribution. Okay, there I get the result. Now I can just say, give me, find the expectation value of X cubed, let's say, with X distributed according to that log normal distribution. That wasn't terribly exciting. The answer was e to the 24th. Let's see if I make this much more difficult, and maybe it won't even be possible. Let's say it's X cubed over 1 plus X, and see whether I can evaluate that distributed that way. So let's see. Someone is asking about well, I can show you all kinds of stuff. I'm not sure exactly what you want to do with Bayesian statistics, but there's lots of different things there. But someone is asking about functional reactive programming. So we have this whole mechanism for whole dynamic mechanism that we've had for 20 years actually, that allows one to do so. For example, let me see whether I can make something there that is useful. Let's okay, let's see if I let's get an image here. See if I do current image, and then I have to, let's see, I need to tell it which I need to, let's do this. Let's say image capture, and hopefully it will allow me to control which device. Let's try that one there. All right, let's see. Oh, that's a thrilling image of my desk. Here, let's put something good in the middle there. Okay, so now we should be able to do a current image here, and it should be able to get what is going on there. Let's see. I need to get this so that it is auto-completing correctly, and I don't know what's happened to me here that's causing that not to occur. So I'm going to actually quit this notebook and see what happens. I may have been running a new version that is even newer than the 11.3 that came out today. But so let me make sure I'm actually running the correct version. And that's also a bit strange that it's not connecting to the cloud immediately. What did this just do? That just reopened that notebook? That's very odd. Okay, let's go ahead and start a new notebook. And let me go to 150% again. And let me see whether this strange problem has gone away. Oh yeah, there we go. Okay, we're all good. Okay. Let's see, where were we? We were trying to do current image. Let's see whether current image will pick up something. Okay, so I think we need to do, I need to tell it which imaging device to use. And I wonder who that documentation writer was. Okay, imaging device, dollar imaging device. Okay, let's go dollar imaging device. Let's try dollar imaging devices. That will tell me my various imaging devices. And I want that creature there. So that's the fourth imaging device. So I want to say dollar imaging device equals that thing the third one of those. Okay, now let's try current image. There we go. Okay, that's my desk with a nice patch there. Okay, so we talked about dynamic. So if I say dynamic of that, I can go ahead and I can do a computation on that. For example, well, let's just do dynamic image there. I can just put my hand in there and wiggle it around. But let's say I do a more non-trivial computation. I could, for example, a typical thing I might do. Let's try living really dangerously, okay, just for fun. Let me do this. Let me take, well, I can just do a trivial thing like I can just do edge detection. Okay, but that's no fun. I can just take the current image here and edge detect from it, and I'll get that. And I could say here and make this work dynamically. I can just say dynamically edge detect that. And now I can get something where I can move it around like this. But let me do something more ambitious. Let me say, instead of doing that, let me take that thing and let me go ahead and say, actually, here, let's do this. Let's just do this. Let's just say chromaticity plot 3D. Okay, so what that's now going to do is it's going to show me in real time so I can probably move it around if I want to, but it's going to show me in real time there. I'm putting the red. It's actually, I should probably, let me put another one in here so you can see what it's doing. So let's do another dynamic here. Go ahead and say dynamic of current image here. It's really burning a lot of CPU effort to keep updating that, but now we'll be able to see both of them, and now we'll be able to see if I put that red much closer, there'll be many more red pixels there. Okay, so that's kind of an example of how you can do dynamic things in our language, and works really very generally. I mean, you can do that. Okay, let's see. Somebody's asking about deep learning and training. Yeah, you can absolutely do training. I mean, we can do a simple training and then let's do a less trivial training. I mean, if I just say, let's go to our neural net repository and we can say net model of, some simple network like Linnet, for example, and then we could get the untrained initialization network for Linnet. Untrained, okay, I probably want no? Oh, there's an update available. Great. It's actually, I'm just going to, it's kind of interesting to see what it looks like, actually. If I go ahead and update all the neural nets so this is a neural net that I must have downloaded previously. Okay, so these are neural nets that I downloaded previously and other things that I downloaded previously that I just got updates for. Okay, so let's go ahead and get that network. Here, let me copy it down here, and let me just, to organize myself, let me put in this notebook, network training. That's going to be the section that we're going to be working on here. Okay, so here's a network, right? So we can look at this network, and it's an uninitialized network. So if I take this network, I could say net initialize on this network, and that'll give me a randomly initialized network. So if I now I might take the MNIST data set, so I could say resource data of MNIST, so that's in our data repository, and I could say, give me a random sample of, well, let's just get the whole MNIST data set first. Okay, so now it's going to download the MNIST data set, and it'll take a little while probably to format. It's maybe, I don't know how big it is, 50,000 things. Okay, there's a bunch of handwritten digits, okay? So let's feed this totally randomly initialized neural net up here on line 14. Let's feed it a 0. And we can guarantee pretty much it's going to give some stupid answer like 5, right? Because it's an untrained network. But now if we wanted to, we could take that randomly initialized network on line 14, and we could say net train that network on line, let's see, we can just take this network here. Should be able to take that network and say, train that on a random sample of, let's see, of the MNIST data set. I'm just making a line where you can see everything going on here. Let's say a random sample of 2,000 elements from the MNIST data set. Oops, let me do this instead. So let me just take the thing on line 14. Okay, here we go. So this is now, oh, okay. All right, so now this is actual training going on. So what it's going to do here, oh gosh, it's going to train too quickly for me to be able to talk about it. So what you see here, the error rate is going down, the loss is going down. So this is now training on 2,000 samples, 2,000 randomly selected samples from the MNIST data set. It's training a network. And what's going to come out now is, after this is done, is a trained network. And let's see what happens. Okay, so there's our trained network. And now let's feed in a 0 to our trained network. And with luck, it should actually generate a 0. And it does. Now, if we wanted to, we could take a network. What's kind of interesting is to take networks from the neural net repository. For example, let's take one of these. Let's take one of these glove networks. This is a network that gives word vectors. So if I take that and I say happy, it's probably going to give me. It's going to download that network. Oops, it's a fairly big network, 250 megabyte network. This is a network that is trying to give essentially meaning vectors for words. And let's take a look at what happens here. So we can go ahead and, come on, just have to download it. And then that network will then be local on my machine. By the way, if I was doing this in the cloud, it wouldn't have to download it because the network is already right there in the cloud. But then I wouldn't be using my own machine CPU. I will be using the cloud CPU. Okay, so that was the word vector for the word happy. So let's do this. Let's pick 50 random words in English. I could do it in a different language as well, but okay, there are 50 random words in English. And let's go ahead and make a 3D feature space plot. 3D feature space plots are a new feature in version 11.3. So let's go ahead and line 20, and let's say the feature extractor is this net model here. So we're going to use that net model to determine what the features are that we're going to be using to determine where these words should go in feature space. Okay, so what should be happening here, there we go. Okay, so now what we've got is those words, why is it spinning? I don't know. Wake up, computer. So those words, let's make this a bit bigger. And we can see, I don't know what, I can't, I have no, this is not our model. This is a word vector trained on tweets, which we didn't train this. So why beach and luggage? Okay, they're fairly close together. Yeah, there's some pretty weird correspondences here. So anyway, actually, what we could do just for fun, we could see what our built-in feature space plot does for that case. Why is this taking so long to copy? Hold on. Let's just try seeing. There we go. Okay, so this was our built-in feature space plot. That looks a lot more convincing. Friendliness and gratefulness are close together, and godless is unfortunately near gratefulness. Oh well. Mathematician is near mistreatment. Okay, I can't speak to that one either. Okay, so let's see. I'm trying to. So somebody's asking about deep learning training. I showed you an example of that. We can do a much more serious training, and you can do it. As a matter of fact, one of the things that's new in version 11.3 is MongoLink. So MongoDB is a database system that's good for managing. It's actually what we use internally to manage large-scale training in the cloud. We actually, and this is now a bunch of functions to support using, dealing with terabyte-sized data sets using MongoDB, and that's what we use with our machine learning training system, which is ultimately based on MXNet. We use that to train in the cloud. We've been big contributors to MXNet. I think you asked about Amazon. Amazon, I think, is also a big contributor to MXNet. Don't know if they're bigger than us or we're bigger than them in terms of contributing to that open source library. Okay, let's see. Is there a new way? Is there a standardized way to analyze and report data? For example, if you're classifying data, well, yeah, you can do things like, for example, let's say I pick. What should we do here? Let's do this. Let's say well, in fact, this feature space plot is a pretty good example of, but we could do some clustering. So for example, if I took, I think I had those random paintings. So let's say whatever it was, I had Monet artworks. Let's try getting a list of those. Okay, so I was using natural language understanding. Okay, so I've got a bunch of artworks here. Let's go pick entity value that, comma, let's just take the first, let's take the first 20 of those, and let's try and get images of those. Let's see how many of these pictures we have. Okay, so we have all but one of those. Okay, so one thing we can do if we're trying to do some analysis on this is something like delete missing of that to get rid of that missing one. The first thing we could do is just do a feature space plot. And then that will show us sort of how those pictures are distributed in a feature space. So those various haystacks seem like they show up together. I guess this, whatever that picture is, very watercolory type picture shows up together. We could also do something like, how about clustering tree? So we could say clustering tree of the images on line 25. And so now that will be a different kind of analysis that will show us how those images cluster, how we can make sort of a phylogenetic tree. So if these were images that kind of had evolved one from another, we might learn about that from this clustering tree. We can do all kinds of other computations on these images and get results from that. Let's see, when will n-body simulation be implemented? As a matter of fact, if you watch some of our live streamed design reviews, you might know that we're actually working on a very general n-body simulation system. It wasn't ready for 11.3. It will be ready for the next version. Let's see, somebody here is Jose Ignacio Escudero. Jimmy is saying, I published wolframalpha.net, an open source library that lets you work with Wolfram Alpha APIs from .net. Very nice. Cool. It's in general, you know, you can, I mean, making an API in Wolfram Language is very easy. You can, let me just show you how you'd make an API. Let's make an API that, for example, let's make a picture of an animal. Let's make an API that makes a picture of an animal and the color negated version of the animal. Okay, so to do that, let's first of all make a form that says you type in an animal and let's see, it's of type animal. I think that's a type. Let's just check that that's a type. Interpreter, animal. Let's see, if I type in ox, for example. Yeah, good. It knows that it interprets that natural language there. Okay, so here we go. So now let's say we're going to go, let's say with an image that's equal to hash animal. We'll get an image from that. And now we'll say that image, let's get let's say just a list, the image and the color negation of that image. And let's maybe, I don't know, we can do something more fun with it, but let's just do that. And let's say we're going to return that as a PNG. And now let's just say cloud deploy that. So just make that something available in the cloud, and let's actually make it so anybody, if you write down the URL, you can just go there. We can make it a public deployment. So let's go ahead and do that. Oops, I forgot a very important thing here. I forgot to tell it that this was going to be a function. Okay, so now let's go there. Now this is going to go, what did I do horribly wrong? Oh, I did that. That was a horribly bad idea. Let's deploy the right thing now. Okay, so now this will deploy as a form on the web, and it says, fill in an animal. So for example, I could fill in an ostrich, for example, here, and let me go ahead and run it. Okay, that's cool. So there I've got a picture of an ostrich. Now, why did I get this? Oh, what did I do wrong here? I said, with that, color negate it. What did I do wrong with my ostrich? I should have had an image and the color negation. Let me see what happened. Let's take that image and oh, that's funny. Okay, what I did there was I made an animated PNG. I just gave the PNG a list of images there, and that will have made an animated PNG. So actually, if I really wanted to live dangerously, I would let's do this. Let us do this. We could make a successively blurred ostrich if we wanted to, but let me do something which isn't quite as silly. So let's say graphics row of those, and let me redeploy this. And now let me try an ostrich again. And there we go. Now we have the ostrich and the color negated ostrich. It would be fun though. Let's make an animated ostrich just for fun. Or let's make an ostrich. I'll tell you what, let's go ahead and make something. See if I can make this work. Let's go ahead and make something where we actually have the image there, and we say make something where we can manipulate the image, and we successively blur the image by, okay, here we go. This is really kind of high tech, but let's see what happens here. So let's say blur that up to 20 pixels. And now I want to close that, and I want to do that. And let's try, what did I do wrong here? I said, I've been doing crazy surgery to this. Okay, that seems right. And now I want to end yeah, there we go. So there's the form function, and then I deploy it. Okay, so now what I should get here is when I deploy this, let's try a different animal. Let's try a giraffe. What I should get here, see whether this works, is I should get an interactive interface. There we go, which has a giraffe in it. And I can go ahead and, isn't this cool? I can go ahead, so I just deployed, I just said make an interactive interface here. And as I move the, so I just on the fly created an interactive interface that will make me able to blur the picture of the giraffe. Now, let's take this one back here, because I was talking about APIs, and let's turn this thing into an API function. So now this will become a web API. If I don't give it a parameter, it will just fail. But if I say $animal equals antelope, for example, then it will run that computation and generate a picture of an antelope. Okay. And if I wanted to, just for this particular API, I could say, make me the embed code for this in, let's say, do we have, let's see, how do we say .NET? Well, let's do, let's just say Java here. So that's now embed code, Java embed code that will call that API in the cloud. And actually, one of the things that's interesting now is that if you're making an API that you want to charge for example, you can start doing that because you can set up an API where, for example, there's a permissions key that you need to use, or you can say generate secured authentication key. That's a very long function, but this generates an OAuth key that you can then give to users to be able to call. So this OAuth key would be put in the embed code that you would then put in a program to call that API. So this allows you to do the whole OAuth transaction. Okay, so let's see. Somebody was asking here, is there an efficient way to implement Monte Carlo, Markov chain Monte Carlo? Sure, let's see. Markov chain Monte Carlo. Yeah, we actually have a whole lot of things. This is not new in version 11.3, but I can, well, let's just look at what, we have a whole lot of stuff for doing that. Yeah, look, here's a random process. Here's a guide to random processes. So for example, we could say discrete Markov process. And so for example, let's take an example here. So this actually represents a discrete Markov process with, okay, so that means that's an initial state 100, and those are the transition vectors. That's the transition matrix. And now what I could do, okay, I can compute, let's try to compute. So let's say that's the process. Now I could say, let me try doing this again. I'm living a little dangerously here. Let's say random, let's see, how do I do this? What I want to do is I want to work out I want to give you a Monte Carlo simulation of that random process. So I can say, I could ask for the stationary distribution of that process, and that will give me, that will just compute something which I think is probably analytically computable there. It says the stationary distribution of that Markov chain is the discrete uniform distribution 1, 3. But I can also do I could also, I think, do a here we go, simulate a random process. Here we go. So what I want to do then is I'll say a random function using the discrete Markov process, line 37. I think I know what I'm doing here. Well, let's see whether this works. 0 to 20, for example. Okay, cool. All right, so now, I wonder what happens if I just say date list plot of that. Yes, okay, so that is showing me a Monte Carlo simulation that has been done of a single path in this discrete Markov process done by running that thing. Now, if I know what I'm doing here, which I'm not sure I do, there we go, generates an ensemble of n pseudorandom functions. Okay, so let's go ahead here and say, let's say 20 pseudorandom functions. Okay, now let's plot this. And now what we'll get is 20 samples of that Markov process, okay? And if we wanted to, I could now say, I could now do computations on this. I mean, I can make a more exciting Markov process, but that perhaps gives an idea how to implement. So this is, you're asking, are there ways to implement Markov chain Monte Carlos? I think that's the answer. And I can get the distribution out from that and everything. Does Wolfram Language include database of word meanings? Yes, it does. If I say, let's do this. Let's say, it's always fun to say, you can estimate how many words you know in English by just picking, let's say I have 10 random words, and let's see if I know the meanings of all of those. I think I do. Open work. I'm not completely sure I know what that is. Anyway, I could say, give me word definitions of those. I have to say word definition of each of those things in line 43. And now it'll have to load in some data, but it should be able to give me those definitions. Okay, there we go. And yes, we can obviously get synonyms and things like that from this. We have a whole network of word functions that does things like this. And actually, if we let's just take something like this, and just for fun, if we're interested in words, we can do something. A lot of sophisticated things actually coming through machine learning, but one thing here. Okay, actually, I need to show you a couple of important things. Oops, I need to say, oh, that's not what I wanted. Silly me. This is going to make a parse tree from that. Using actually neural network methods, it's going to make a parse tree, and that does not look right. What is that? Grammatical unit missing. How odd. anyway, okay, I want to show you something, and I'm going to come back to this. I want to show you something that's new in version version 11.3, which is so let me just pull in the Wikipedia article for ostriches, about ostriches, just because I want some text data. Okay, so let's say let's just call this ostrich. And now, for example, I could take ostrich there, and I could go ahead and say, I could say, make me a word cloud of the words in the article about ostriches, and it'll probably give me a word cloud here. Or I can say, this is the new thing. I can say, find textual answer. And now this is using state-of-the-art question answering technology. So let's see. How fast does an ostrich run? And let's see what it does. So now it's going to have to load in a neural net to go do this. It's a big neural net. Actually, we can go see in the neural net repository what the neural net actually is. It's taking its time to figure this out. It's a big, long article about ostriches. So it's, okay. That's fascinating. Okay. It's a slightly silly answer, I would say, but not obviously totally stupid. Let's see the top 5 answers it got for how fast does an ostrich run. It's saying, okay, well, it's 270 kilometers per hour. Okay, there's some slightly goofy things there. I wonder whether we know, actually. I don't know whether we would know it. I think Wolfram Alpha, oh, there we go. That's cool. So Wolfram Alpha says it's 45 miles an hour. Let's see how that compares to unit convert to what it said in the Wikipedia article. I'm guessing, as a human, I can kind of guess that this is the most likely. I could, for example, select these for ones that are quantities that correspond to speeds. But I could also just say unit convert. Actually, I just say unit convert of that. It tells me in meters per second, so I can say unit convert that to kilometers per hour. And then it says, oh, wonderful. Okay, that's kind of interesting. So the Wolfram Alpha, from our knowledge base, it's saying about 42 miles an hour. Here it's saying, I mean, for 72 kilometers per hour. Here it's saying 70 kilometers per hour. But what's interesting is the extreme non-triviality of being able to do this question answering, which, of course, like many of these things, isn't perfectly reliable. So if I say, what does an ostrich eat? I have no idea what kind of thing it's going to come up with. Let's do 5 of those, and let's see what it comes up with. Okay, insects such as locusts. Okay, so there's only one here that actually is a human, looks plausible, and that's kind of life doing natural language processing. But this is a lovely state-of-the-art thing, and actually we could go ahead and we could say, wonder if we have it. See whether, I'm not sure if this is loaded up to the neural net repository yet, but coming soon will be the actual network for find textual answer. Okay, let me go back here. Somebody's asking, if I buy a non-subscription lot, for how long will I have access to 3,000 API calls per month? Sadly, I am just the CEO and I don't know the answer to that. You can deploy APIs and you get, depending on which plan you have, you get some number of free API calls per month. I believe these, I mean, these API calls are not, unless you're grinding us CPU for an awfully long time, these are not expensive API calls. Let's see. So in summary, we can use pre-trained neural nets from the repository, but the option of training our own DNN models in the cloud rather than locally is not ready. No. You can absolutely train these things in the cloud. You can use our cloud to do training. I'm not sure that's the most economical thing to do. The option of using, for example, the Amazon cloud for really large scale training is, well, you can do that, but it's a little bit of a do-it-yourself kit right now. We have all the technology to do that, and we will be releasing it fairly soon. In terms of building your own models, no, you can absolutely build your own model however you want. We're really proud of the symbolic. Let's take an example. Well, let's just do something like let's take an LSTM, for example, and we can build up. Let's try and see whether there's an application here. Oh, these are kind of complicated. Unfortunately, as soon as you get to sophisticated, okay, well, there's an example. Okay, there's an example. So that's how you actually build a neural net from scratch in our system. Okay, so there was a net encoder here. This is a little bit complicated because we've got to have a net encoder to get the input. But let's just take a look at what happens here. So there, what you're seeing is this is generating a neural net. It's an uninitialized neural net here. And you are, so I could initialize it, or what you're seeing here is an LSTM layer, these linear layers and so on. What's extremely non-trivial is that you can fit these arbitrary length sequences all together in this. And for example, if I say net initialize, it will initialize that network randomly in this case. And I don't know what this actually takes as input. Let's see, characters, digit character, and a plus sign. Okay. So if I feed into this, and this is probably going to do something totally ridiculous, but let's say I feed in something like this to this uninitialized neural net, so it's going to produce garbage. Okay, so that kind of amusingly, let me just try, because it's one of those things where you just have to have memorable moments for what neural nets do. It's not easy to teach neural net arithmetic, and now we're asking this particular untrained neural net, the newborn baby neural net, what is 2 plus 2? And the answer, it says, is minus 0.02. Now, hopefully, if we trained it, it would know better. But this is roughly how you start building up neural nets from scratch. And you can then go ahead and do training on this and so on. And the point is, you can take a neural net from the repository and you can take it apart and do that, or you can build your own neural net from scratch. Or you can glue together pieces from the repository and so on. Okay, somebody's asking about blockchain. Let's see. Somebody is asking about bioinformatics. I don't know. I mean, let's just do, just for fun, let's do a little bit of bioinformatics. Let's say, let's just do, okay, let's start off with something really basic. Let's say I pick a random base pair sequence here. Let's see what happens. No hits on the human genome by default. Okay, so there are some hits on the human genome to that base pair sequence. Let me try. I'm going to try. Let me do something totally outrageous. Let me do. Let's do genome data, and let's do. Let's see what I'm doing here. I might need to look up how this works. Mitochondrion. Let's see, I want to do the strand. Let's do the positive strand of the mitochondrion, and let's try and do the whole mitochondrion there. And let's go ahead, see whether we get the human mitochondrion here. And while it's looking for the human mitochondrion, I am going to go somewhere else to a little secret stash of data that I have here. And let me see if I can do this. Where would it be? Hold on one second. Sorry, just a moment here. I'm hoping I'm going to find, if I'm lucky, I'm going to find a, let's see what I have here. Yes, I might have what I need. Okay, what I'm going to do here, if this works, I'm going to drag over from here. I'm going to drag, there we go. That should be my mitochondrion. So let's call it SW mitochondrion. I've had this sequenced an awfully large number of times now through having had my whole genome sequenced back in 2010 and various other sequencing adventures. Okay, actually, you know what I want to do? I want to say, it's just I just want to get the actual string there. So there's my mitochondrion, and there's the reference mitochondrion. on line 65. And so the obvious thing for me to do is to say sequence alignment of the reference mitochondrion, which was on line 65, and SW's mitochondrion, which was there. And now it'll go and do alignment for these two things. Okay. You know what I did? I got the wrong strand. My mitochondrion, let's take a look how it starts GAT, and this reference one, no, it's also starting GAT. All right, so maybe there's, what did I do wrong here? GAT, what did I do wrong? Am I asking it to do, oh, no, I didn't do anything wrong. This is exactly right. Okay, this is exactly right. This is saying most of my mitochondrion is exactly the same as the reference mitochondrion, but here is the first SNP, my first variant SNP. And then there are a few other variant SNPs. Let's find out. So we can figure out, for example, let's see, let's find out how many variant SNPs I have. So let's just say count in that the number of blank blanks like that. So therefore I have 47. I am a pretty average human with 47 variations from the reference mitochondrial DNA sequence. We have actually a lot of capabilities in these areas. We actually have one big thing that's coming is the ability to deal with arbitrary molecules. Okay, so let's see. Someone's asking about blockchain. Okay, let's talk about blockchain. Nice topical area. All right, so we have several ways of interacting with the blockchain. Let's first of all, let's go ahead and set the blockchain base to be Bitcoin. This will be the main Bitcoin blockchain. And so I can say blockchain data of, well, for example, I could just say blockchain data for that main blockchain, and that will tell me that there are 500,000 blocks on the Bitcoin blockchain. But more interestingly, I can say blockchain block data, and I could, for example, say, what's the most recent block that got added to the Bitcoin blockchain? So there it is. It just got added, just got mined, 10 minutes ago. Wow. Yeah, well, that's the Bitcoin blockchain. Okay, so we can see there are a bunch of transactions. We could go pick out a transaction here, and now we can go and say, wow, lots of transactions in that block. Wow, that's a lot. So we can say blockchain transaction data, and we can pick out that block, and there we can see, well, okay, so let's go ahead and just see what was transferred there. So that's that number of Bitcoin. So let's see, we can say that, and we say currency convert that to US dollars. Wow, okay, so somebody just transferred $82 and their fee there, let's see how much it's costing to do something like that these days. Their fee in Satoshis presumably is, that's crazy. It's costing $12 on the Bitcoin blockchain right now, as of 10 minutes ago, to transfer $82. That's pretty weird. So we can go ahead and we can do the Ethereum blockchain as well. We can look at transactions there. But let's. Someone was asking about our blockchain. So we actually have a Wolfram blockchain, which is uses the Bitcoin core right now, and it's a blockchain which allows you to make essentially a ledger in our cloud or in a private cloud. So actually, with our blockchain, I mean, there aren't very many blocks on our blockchain, and if I say blockchain block data, and I look at the most recent block on our blockchain, it'll be, hopefully, wake up. There we go. Okay, so it was mined more than an hour ago because there isn't yet much activity on this. We've only got 2,800 blocks on there, but we can do nice things there. So, for example, let's put let's pick 5 random words, and let's just say, let's just take a graphic. And let's say graphics of circle. No, yeah, we can just take that graphic and we can say blockchain put of that graphic, and that will put that graphic onto our blockchain. Okay, and so that means that we can be sure, because our blockchain is being sequentially added to and so on, and we're also going to be publishing hashes of our blockchain in various places. You can then be sure that this really was put there. And if I say blockchain get from that address, it will go ahead and retrieve that original circle again. Okay, so the idea of our blockchain is to provide a convenient ledgering system for people who have, who knows what, lab notebooks they want to confirm. They might have some assets that they're trying to make a registry for. We're just providing a convenient way to do that. I mean, I have to say that it's the whole world of smart contracts on the blockchain and so on. We are in this very, very interesting position because Wolfram Language is a language which can make statements about the real world, and it can also connect to IoT devices and so on in a good way. And this allows us to basically support serious smart contracts that can be operated from a blockchain or can be operated not from a blockchain. Lots of very interesting things coming in that area. This reminds me of a very important new area in 11.3, which I really want to show you. This is a big, big new area for us. This has to do with being able to get models of devices in the real world right in the Wolfram language. So we've had this product called System Modeler for a number of years, which is a very industrial grade system for designing and simulating large scale objects. So let's take an example. Let's see, this is a little interface here. So let's try heavy equipment. Okay, let's see what happens if I try an excavator. This may be very elaborate. Should be an excavator arm, but let's try copying the model. This may be a big mistake. Whoa, 6,630 equations. Okay, that is a serious number of equations. You know what? I'm going to, before I do the excavator, I'm going to do something a bit simpler. Let's try just educational examples, or let's try one in aerospace engineering. Okay, so this is some kind of satellite thingy. Let's copy that model. And now what on earth actually is this, we might ask. Let's wait for it to wake up. Again, this might be a fairly complicated model. Well, let's try it. Okay, so here's our model. And this is a model with a bunch of components. And ultimately, this model is represented as a whole lot of equations. But we could say here something like system model simulate. Actually, no, let me start off with just system model plot. So what system model plot is going to do, it's going to take the kind of most obvious variables here, and it's going to do a simulation of this model over a certain period of time, and then it's going to plot the result. Okay, so it's actually doing some very crunchy things. It's doing all sorts of low-level compilation. Okay, so now it did a computation. Okay, there we go. So this is now computed from that model. It's now computed. It's now essentially solved the equations of that model to compute these results. You know what? I'm gonna start off with a simpler model because I think it's going to be more obvious what's going on. So let's go back here and let's say introductory examples, and let's try systems. Okay, let's try an inverted pendulum here. Okay, so this is going to be a quite simple system where we have a, okay, so this is our inverted pendulum, and then we say system model plot, and then I'm going to show you, so this is now compiling the model, and we can go ahead and there is the result for our inverted pendulum. There's the angle of the pendulum as a function of time, et cetera, et cetera, et cetera. Now, what we can do here is we could actually go and change the parameters of this. So if I go in and take that model and I say, and I just ask what properties does that model have, it'll probably have all kinds of properties. So for example, let's say I take parameter values. Let's say I ask it, what parameter values does it have? Then I can get those, and then I should be able to, okay, so this is going to give me values of the parameters, hopefully. Wakes up, what's it doing? Maybe this is not so trivial. What am I asking it to do? Maybe it has a lot of parameters, not sure. Well, let's try, I'll tell you what, something which I think must be a lot easier for it. Let's just ask it input variables. Oops. So, I don't know why this is taking so long. I'm trying to just get this to show me, why is this so complicated? Let's see. It's a bad sign. The point here, anyway, is this is oh, there we go. Oops. Oh, that's why it took a while. There are tons of them. What a mess, my gosh. Well, let's try taking. I got to have a simpler. Let's do this. What I wanted to show you was how you can parametrically scan across different features of parameter space for this model. But let me go back here where we had that a nice little thing here, and let me just go and we go back to the examples, and let me go and show you just individual components. Okay, so let's just say, let's try something really simple. Okay, this is some kind of circuit. Before we get any more complicated here, this is a circuit with some, it looks like it has some inverters and things in it. Okay, let's look at that circuit. Okay, what does it have in it? I'm not sure I can read a circuit diagram anymore, but I think those are inverters. Okay, so let's take this and let's say, we say system model plot. This should be a bit simpler. Now it'll hopefully generate, okay, that was really boring. So that's what I get for having finally a simple model here. So let's just say here, let's see, what were they called? I think we want to call it, yeah. Let's just say for this model, let's ask, what are the equation, what are the, let's see, parameter values for this model? Okay, that's a bit simpler, right? So those are parameters like the gain of the system and so on, okay? So what I could do if I wanted to is I could say system model plot, and I could say there, therefore, I'm going to take that system model, and I'm going to say system model plot that, and then I'm going to give a parameter value here, and I am going to say, let's say gain, that gain, and now I bet nothing interesting is going to wind up happening, but anyway, let's try it. Let's say that gain goes from, is n, and I think this is the right way to do it. And let me just make a table of those things with n goes up to 4, for example. See if this works. Oh, silly me. Okay, let's see how this works. When in doubt, read the documentation. So what I need to do is plots variables and sensitivity bounds when the parameter value p, okay, so this so what I want to do here, okay, well, that's just plotting a particular, let's just do that. That's something that's kind of interesting to see. So if I just look at the variables from this, I will be able to see what I can plot from this. System variables is what I want. Okay, so there, for example, I could type something like this gain 3 dot whatever, and then I could say, actually, what I'll do, let's go ahead and plot a whole bunch of these. Let's just plot all of those. Okay, so let's go there. Why is this doing that? Oh, maybe that will work. Let's try it. Yeah, there we go. Okay, so that's plotting now multiple variables there. Just for fun, I could take this and I could say, just show me the actual equations that you're solving in this very simple case. And okay, so in this simple case, there are only a few equations. In the case of that excavator arm, there were 6,000 equations. Okay. By the way, so someone's asking here about private blockchain ledger with Wolfram Language. The answer is, if you have a private cloud, absolutely. If you, I believe we have some information about how to set this up now. It's a little bit complicated because setting up we're not, if you have the packaged private cloud, you will have the stuff to have a private blockchain. But if you want to do it like on your own computer, that's a significantly more complicated proposition. Sorry, we're not solving that problem yet. But what we can show you is, what did I just do here? Here's actually what I wanted to show you there is a new type of documentation that are called workflows. And I wonder whether we yet have the workflows about, okay, no, we don't yet have workflows about blockchains. So, right. With respect to our public blockchain, our public Wolfram blockchain, you pay for that with what are called service credits. And well, it's super cheap compared to Bitcoin, given that we just saw that Bitcoin was costing $12 per transaction there. Okay, let's see. So let me show you a few more things which are new in 11.3. And let's go back here. So I can go back and look at my crib sheet so I know what I'm forgetting. Oh yeah, let me show you, talking of, let me show you a completely different kind of thing. This is sort of in the department of data that you can, hold on a second here. Data that you can get in Wolfram Language. So this is now data about your computer. So if you say system process data, what you will see is that's the processes running on my machine. There are 215 processes running on my machine. So for example, I might say, let's look at memory usage here. So this is now all computable. So we can say all this comma memory, and this will tell us how much process on my machine is using. And for example, I could say, make me a histogram of that. See if this works. There we go. So that's showing me a histogram of the amount of memory used per process on my machine. Actually, one thing I'm curious about is, can I make a graph that shows what process calls what other process? So if I take this system process data there, line 97, and I say, give me all comma PID for the process ID, and actually let's do PPID comma PID. Okay, so this is now going to give me hopefully all pairs. Okay, very good. That gave me the pairs. So now let me just take that, make that a normal expression. Okay, so now what I want to do is for each of those, I want to take the values, and now I'm going to make this into a graph. Okay, values there. And now what I want to do is I'm going to do something. Let's take those. Ooh, there's some missing key absent things. Okay, well, let's not worry about those for a second. Let's go ahead and say apply rule to that. Okay, so now we've got basically a bunch of rules that say how processes, what the parent process ID was going to the actual process ID. So now let me make a graph. So this is now showing me a graph of what processes. So that's probably PPID1 is, let's do this, just saying vertex labels arrow automatic. It's going to make a bit of a mess probably. Okay, so that's showing me all the processes on my computer that, okay, so what this is showing me, PPID1 is spawning lots and lots of these processes, but there are some weird ones like process ID 426 is some kind of marooned process not connected to PPID1. So that's an example of something, sort of a new kind of data that we can deal with here. Let's try something different. Let's try something really outrageous. Let's see, someone's asking, when will 11.3 be available to download? I believe it is available as of today. So go right ahead. You can also use it in the cloud. But yep, it should be available today. Okay, let me show you something else. This is another weird thing. So this is something where I can say network packet recording. So let me go ahead and record 0.1 seconds of network packets on the network of my computer. So this is now recording from my, it's very kind of low level, but these are network packets. And so let's take a look here at, so this is 67 packets were exchanged through the EN0 interface of my computer. And so, for example, let's say I go to, I'm actually curious what the packet types were here. Let me see. Let me just see. How do I get that? Let's try and figure out. Let me see. What would be the packet type? Ethernet packets, but what? Let's look at one of these. There we go. Okay, so that is a TCP packet. And that is showing what actual ports. So I don't know what, let me see what happens if I taste TCP port. No, that is a, wait a minute, I want to say port 443. It doesn't know what that is. Okay. But what that's showing me is a raw low-level packet. What I thought I might find here is packets. Oh yeah, there we go. There we go. Okay, that packet is me talking to you. That's a UDP packet, and that's almost certainly a UDP packet that is going out, that is taking audio, or might be a UDP packet from my screen. Actually, if I wanted to, if I really want to sort of live dangerously, I could copy data to clipboard. I can go ahead. There's the actual byte array. So let's say, I mean, I don't know what I need to do here, but that's the actual sequence of bytes in that UDP packet that was transmitting some piece of audio or transmitting some piece of my screen. Actually, if I wanted to, just for fun, let me just capture some audio. So I can talk to you here. I think that this is going to capture audio from the right microphone, but we'll find out. Okay, so let's go ahead. Hello, hello, hello. Okay, let me say something here. Okay, if we're lucky, that will have captured the audio. Let me see. That is not a good sign. That suggests that the audio input device is not the device that I'm talking to you from. Oh well. so much for me showing you a bunch of new audio tricks. I wanted to say, somebody was asking about download. I should say that if you are at a company or university that has a site license for Mathematica and Wolfram products, it may not yet be available through your site administrator, but it will be available by Monday. Okay, anyway, going back here, let's talk about some other pieces of new functionality. Well, there's some very practical. Oh yeah, here's an interesting one. Here's an interesting one that I probably can't demo to you, which is external language cells. So I just so here I'm typing into. Ooh, fascinating. I just created a Python cell there, and I just evaluated that in Python. And I'm afraid I don't know Python, so I don't know whether I can. If I do something like this, I think that's not power. I think that's bit XOR or something like that. That gives me a result. But I could take a big lump of Python code and just paste it in here, and then just evaluate it in the system. I don't know what. Oh boy, I'm really embarrassing myself here because I really do not know Python. So let's see whether I can. I'm just going to guess something here. Does this work? Anything like that? Blah, syntax error. So it goes. Well, just proves I don't know what you ask me Wolfram language, I can do that very well, but Python I cannot. Another thing we have, so we have our external evaluate function, which can evaluate things in Python or JavaScript, soon lots of other languages. A new thing is being able to do basically remote control a web browser. So I can say external evaluate WebDriver Chrome. Let me go ahead and look at the documentation for this. And now I can go, there are various external evaluator types. So here, for example, I can go Chrome. Okay, external evaluate usage. Okay, so these are different commands that I can go. So I can say open web page. So I think what I do here is I can say open web page, arrow. I assume I have to say http wolfram.com. And let's see what happens. Magically, Chrome will open somewhere. The only question is where. Is that it? No. That is odd. Okay, so somewhere probably on my screen, unfindably to me, Chrome opened a web page. But let's see what happens if I say, I think I can do capture web page. Let's see what this does. There we go. That was cool, wasn't it? So there, what I did was I remote controlled Chrome. I told it to open that web page. That gave null. And then I said, go capture that web page. And it gave that result. Okay. So let's see. People are asking here. Okay, somebody is telling me that power in Python is wedge. So let's try that. I mean, star. So let's just try that. Okay, works. And it reads back the big num even. Okay, you're asking if we can connect to a Node.js server. The answer is yes. If we go here, you can pick Node.js. Okay, what's power in JavaScript? Let's try the same thing. He says, oh, that's unfortunate. Let's see whether I can, maybe I don't have Node.js installed. Okay, then I might have to use the system install function to install Node.js. So again, you know, if you're out of our ecosystem, it's a little bit out of, you're kind of escaping from the beautiful garden that we have built. Okay, well, so I don't seem to have Node.js installed here. But the idea is you can use Node.js if you've installed it. Someone is asking about R. Actually, we've had a very sophisticated R-Link package for many years now. This is that allows you to do all kinds of things. I have to admit that I'm not an expert in using it, but it's a very full-featured back and forth exchanging data in both directions with R kind of system. Someone is asking about MATLAB. I have no idea. I don't know whether they have any of the kinds of modern protocols that you need to be able to do these kinds of connections. I also have no idea whether their license agreements allow these types of connections. Someone is asking, can we do sheet music OCR? Not as a built-in thing. That would be an interesting thing to try and train the system to do. We've done a whole lot of experiments on math OCR. People have built some fairly nice math OCR systems using our technology. Sheet music would be an obvious cool thing to try, and it should be a really good thing to try out. All right, let me go back here to let me see where I was. Yeah, I was going to go back. Oh yeah, here, this may be no fun. I wonder whether speech synthesize. Well, here actually, I could do speech synthesize. That would give me a waveform actually. Okay. Let's do Pod Bay Doors. In celebration of the fact that it's 2001's 50th anniversary coming up in about a month, let's try doing this. And that should give us an audio object that now, oh, you know what? I maybe was just doing the wrong thing before. What an idiot. I was doing the wrong thing. I think my audio capture may have worked just fine. So here, let me pause this. Now I could do, for example, for this, so this is now streaming audio. This is now synthesized the audio for open the pod bay doors. And now I could do spectrogram of that. Okay, there we go. Now I'm curious if I do an audio capture and I can channel poor Dave there, open the pod bay doors. Okay, now let's do a spectrogram of that. And there's my spectrogram. And it's interesting, actually. My spectrogram is much lower frequency than this one. Maybe I should have picked a different voice. But one of the things we actually have now is an audio distance function. And I have to admit, I have not used it. But let me see. We have, let's see. This is because we have the ability to take these things in and encode them. Well, I mean, I could do a net encode of this audio and I would get something that could be fed to a neural net. Okay. So someone is asking, the idea is to use Wolfram Language to do computations, send the results to a Node.js server. Send the results to a Node.js server. So I think it's really easy to do that, right? I mean, all you would say is, if you've got a URL, you would say, you would just send something to that URL. And in fact, if I say, let's do this, let's say URL read from http://wolfram.com. And I think what I'll get back is an HTTP response object. So for example, I could take that response object and I can now dig into it and I can ask for the headers, for example, and that will now be the header of my HTTP response object. I could, if I wanted to, I could say generate HTTP response. If I were going, so let's say I am going to, what could I do? I wonder what happens if I just say 1, 2, 3 here. Okay, So that generated an HTTP response. I can't imagine what's in the HTTP response. Let's look at its body. Okay, its body is probably the string 123. But that HTTP response I could now send to I could say URL execute. How would I do this? I want to send that HTTP. I'm sorry. What I really want, that was generating an HTTP response. I want to send an HTTP request to a particular place. Let me show you a very important new thing in 11.3, by the way. Okay, this is actually two major cool new things. Wait a minute. Can you do speech to text here? Not yet, but it is coming very soon. We've been building up to having neural nets that we can get to do speech to text. And even as we speak, neural nets are being trained to do exactly that. So we will have that. What about spiking neural nets in a future version? I actually don't know what spiking neural nets are. So sorry, I don't know. Okay, here's a major new thing, which I'm not sure how well I'm going to be able to do because I may be very lonely doing this. This is a new piece of functionality for doing chat. Now I'm going to see whether I can get, let's see, I'm going to see whether this person is able to chat with me. Okay, so I'm asking, so this is now a Wolfram Language chat notebook, and I have no idea whether I'm sort of hoping, because that's one of the people who's helping manage the live stream this evening, and I'm hoping that they are there. Say hello there, and it'll now send that. Maybe I can say, that is a really bad sign. That's saying that I did not have permission to go to that chat location. So this is using a channel broker. That's very odd. Well, let's try. Maybe that's because it wasn't an accepted chat yet. Let's view the participants in this chat. Channel is unavailable. Humph. All right, let's try a new chat then. All right, let's try same person again. Test chat. Okay, participants will be invited to this chat after your first message. Okay, all right, so let's say hello. All right, let's give that a try. Huh, same issue. How odd. Well, okay, so much for that chat. Anyway, what's interesting about this chat is that, well, you can use it to send code back and forth. It will send arbitrary Wolfram language expressions, although it's carefully sandboxed so that you can't basically send somebody a code bomb. But if you have like a classroom and you have a bunch of students and you say, when you've got an answer, send it in the chat, you can accumulate all of the chat answers in an easy way. Okay, so let's see. Let me show you another major new thing, which is what we call presenter tools. So this is a way of making presentations in Wolfram language. So I can let's pick some theming colors. Let's pick, I don't know, let's pick those colors there. What did I pick here? There we go. And now I will create a presentation. All right, and what happens here, so let's say my title is, this is my title. Okay, so down here, I actually picked it to show something with some sample. Actually, you know what, I'm gonna go back and redo this because I want to show you something with a blank screen. So let's say new presenter notebook, and let's pick that type. let's change the theme colors to those. Let's say, let's not pre-fill the slides with sample content. That will be a preview, and let's now do a create. Oh, someone's asking, how did I bring up the chat dialog? It's under the file menu. It's at the bottom of the file menu. There's also a palette that I think there's a palette. Maybe there isn't a palette. No, okay, so bring it up from under the file menu. Okay, so I'm now going to create a presentation here. It's a blank presentation. And so now let me put in, here is my title. And let's put in I'll put in a subtitle. Oh, that was, I guess that's my, okay. And let's go down here and let's start. Now I want to say, okay, there's going to be my subtitle here. And now let me make a new slide. So I say instead, making a new slide. So let's put in something like, let's put in a manipulate here. Let's say manipulate, I don't know, sine x plus sine ax. Oops, let's say make a plot there. And x goes from 0 to 10, let's say. A goes from 1 to 5, for example. Okay, so now I've got a nice plot there, which I can manipulate around here. And now maybe I put in something. Well, let's just put these in, okay? All right. So now I want to make this as a presentation, okay? So let's just say start presentation. And now this will go full screen. And here's my presentation. Now notice that if I had a smaller screen, so now I can go to the next page. I think I press page down by default. And here we go. Now this is the next page of my presentation, and it's all live. So this is not, it's not PowerPoint anymore. And I can go and just type into the cell, and I can go do computations here. So I might have 1,000 factorial, and it'll scroll probably. So this is now a scrolling, and I could go page up, and I'll go back to my previous slide. Okay, I go to that little control there, and I can say end presentation. And now what I'll find is that the things I computed there, that was a rather big thing to compute, but the things I computed are right there back from my presentation. So for example, if I wanted to, I could add to myself a, how do I do this? Display slide outline. Now what do I want to do? I want to add, see, this shows that I have not yet used this very much. How do I add a note? That's window elements. Come on now. Display slide. Oh, show slide notes. Okay, all right. But now what I want to do is I want to add a slide note. Doesn't contain any slide notes. Okay. Well, that's well and good. What do I want to do here? Set a cell alignment. I think I'm being hung on my own thing here. Where do I put in a slide note? This is all sorts of stuff about formatting. Where do I go here? Let's see. I want, maybe I go to, yeah, I'm actually embarrassedly confused. Clear formatting, okay. Increase font size, that's all well and good. Those are nice features, but where is, oh, maybe I want presentation controls. How about that? No, that tells me whether I'm using page up, page down, etc. Well, I'm very confused by this. Sorry about that. Anyway, it's a cool feature that you can put little notes to yourself in here, and they show up on a secondary screen when you're actually running the presentation. But the big deal here is that if you you know, I could take one of these, for example. I could take, yeah, let's just take this. And I can put that, let's put that in a slide, new slide, put that in here. And now when I do the presentation, oh, there we go, okay. When I do the presentation, it will appropriately size all these things for my screen. So I can do, and if I had a little slide clicker, it would do that. And it's all set up to be, I wonder if I can simulate, let's see if I can do that. See if I can simulate having a smaller screen. Let's go back to the first slide. Okay, let's see what happens. Yeah, isn't that cool? Right, so I'm simulating having a smaller screen, and you're seeing that the fonts are changing size and all that kind of thing. And similarly here, I would hope, if I change size, look at that, isn't that nice? So wherever you're projecting this, it's going to do exactly the right thing. Oops, even if it gets super small. Let's see. Someone's asking, is there a plan for doing math recognized like text recognized? Yeah, probably. Someone's asking about mathpix.com. Yeah, they use our API actually for their actual computation. It looked like a pretty nice math OCR system. Let's see. Someone is asking, how is the compiler rewrite coming along? Very well, actually. I can't demo it right now, probably, but if you watch some of the live streams coming up in the next few weeks, you'll probably see some pretty cool stuff happening with LLVM compilation. Okay, somebody invited me to chat. Let's see what happens if I accept the chat. Okay, there we go. Well, let's see whether this works. Let me see if I can send, let's see if I can send that graphic over. Actually, I don't want an input cell. I just want to paste that graphic, and I want to say send. And hopefully I managed to send that graphic over. Maybe I can send, actually, I'll tell you what, let me send the whole manipulate just for, see, this is really very exotic what I'm doing. I'm taking something out of a slideshow that I was just presenting, and I'm putting it in chat. And I'm going to send a live object in chat. And let's see whether Danielle can send back the live object with the slider moved to a different position. Then I'll be impressed. I've never, I don't know, see, what is it doing? Alt enter to send. Okay. Let's see, are we going to get this back? No? Am I chatting to myself again? Maybe I am. Okay, let's see. What have I forgotten to show you? It's probably some huge function I've forgotten to show you. That's not what I wanted there. Let's see. Oops. Okay, let me try to remember whether I'm missing something. Oh yeah. There's, if people are interested in mathy things. Oh yeah, let me show you a few bits and pieces that are just sort of decorative in a sense. Let's do. Let's say I wanted to do audio here. You'll notice if I close this up, I now get a little opener there. I find that convenient because sometimes I don't notice the closing of cells on the right-hand side. There are some, oh yeah, here's another important thing. Yes, let me show you something that's kind of useful. So let's say I am typing in something like, I just say, you know, range of 30, and I just want, I'm going to say that plus 1. Well, okay, let's say I have that whole thing, and I'm going to say that plus 1, but that's a big long input, and I don't want people to have to see that whole big long input. So maybe I take that, and I can right-click here, and I can say iconize that. And it turns into this just little iconic thing that is still evaluates, it's still, as far as the actual computation is concerned, it still is that list. But the point is that it is shown in iconic form there. So for example, if I were to take, let's say I make a plot of, I don't know what, some function, x minus 10 to 10. And I say, filling, arrow axis, filling style, arrow yellow, all those kinds of things. Let's say I have a whole bunch of those options there. Okay, so there it is. But let's say that I want to not have to have people see those options. Well, I can just iconize those options, and then all they say is that. And now it will still evaluate the same, and people, if they're interested, can go in and look at what those options were, but you don't have to see the options if you don't want to. So that's a nice feature. Another thing, it's kind of geeky, the curry function. So this is a function that if I say curry f comma 2 x y, it will be able to collect those arguments. This is sort of a combinators, etc. play. It's kind of nice because it prevents you, it avoids you needing to define explicit functions. All right, let me show you a few other more sophisticated mathy things. Okay, let me show you something which I thought was going to be completely trivial. So this is something for dealing with equations. So let's say we say 2x equals 4, and we say divide sides, comma 2, then it says it's equal to 2, right? And so this is, and let's say you say comma a here. Okay, oh, that was a little tricky. It had to be a little clever there. So this is like not making the mistake of the elementary student. And this is saying 2x equals 4, great. You can divide by a, but if a is not equal to 0, you get this. But if otherwise, if a is equal to 0, you can't divide by that, and it's still true that 2x equals 4 there. So this is just, and I'm sure if we do an inequality here, things will get even funkier. We could say, let's say, divide sides. I wonder what happens if we do this. Does that work? No. Oh, we can't divide sides. Thus, all terms have equal non-zero signs. Okay. So that's, I see. That's because a is equal to 3, it knows it can just do that division. So this is an interesting thing because it allows one to essentially build up a proof sequence for algebra by just doing this. It's okay. Somebody is saying for use cases, it would be nice if you could name iconize whatever you want. Actually, let me answer a couple of questions here. Okay, hold on. Several different things. Oh, somebody said let's see, the chat. That wasn't quite what I'd intended, but yeah, okay, fine. Yes. Oh, you moved it back to nothing, to 0, and then you pasted the result into chat. Yeah. So we can chat back and forth arbitrary Wolfram language expressions. Okay, let's see. Personal scientific note taking. I have probably by now hundreds of thousands to millions of notebooks that I have used precisely for personal scientific note taking. Maybe for that particular purpose, maybe tens of thousands. This is exactly what I do. I mean, it's oops, that was over there. I didn't mean it over there, but I meant over here. Here's a heading. I start typing things in. Hello there. Maybe I want to put in some mathy stuff. I put, x squared there. Divided by x plus 3, et cetera, et cetera, et cetera. And I can do all of and if I find whenever I'm trying to like organize pictures or something, I always find like if I drag a picture from somewhere, I always find it easier to drag pictures into a Wolfram notebook than pretty much anything else. And what's really cool now is you can take these notebooks and you can just publish them into the cloud, and you can go on using them in the cloud. You can give other people access to them and so on. Actually, I have to show you one thing, given that I showed this picture. So that's a bitmap, but there's a function image graphics, which just got a lot better in version 11.3, which tries to take that, see what it did. It tries to take that and it tries to turn that into vector graphics. So you'll see that this thing was a bitmap. If I make it bigger, that was a nasty bitmap. But yet here, this is using a bunch of techniques to basically turn that into a, and so now if I wanted to, I could actually treat that as a polygon. So I could say, for example, actually what I could do, let's try doing this. Let's try living dangerously again. And let's say image region, and that should try to turn it into a region object. And it didn't, because I probably need to say binarize first, because it probably only does that for things. Let's see. When in doubt, read the documentation. Oh, not the right thing. That's not what I wanted. I wanted instead, oh yes. No, I just wanted the graphic here. And then I wanted to say, I want to say, what did I want to say? I wanted to turn that into a region. So I wanted to say, discretize graphics, I believe, of that graphic. And that should turn this, if I'm lucky, into, it's obviously very big here. It should turn it into a computable region that I can then do computational geometry on. It's probably trying to do this at very high resolution. Come on, wake up. My gosh, what is it doing? You know, when in doubt, let's just see. I think I probably gummed this up with all kinds of stuff. That's what I get for trying to demo everything at the same time. Let's just try doing this. Let's try. Okay, wake up thing. All right, I'm actually going to try just starting a new desktop. And try that same thing again when I don't have all kinds of weird dynamic chat sessions running and God knows what else. So let's see. Something is running very, very, very slowly on my computer. You know what I need to do to figure that out? I need to run that system processes command and figure out, but let's just try this here. See whether this comes back in reasonable time or not, as the case may be. Okay, well, maybe this is really hard for some reason. Okay, so let me answer a few other questions people had here. I saw a wrapper connect Wolfram Language to OpenAI Gym. Yes, reinforcement learning. Actually, in version 11.3, we're starting to have some of the things that you need for that. In particular, we have, this has been a big mistake, whatever I was doing here. In particular, we have a function called net state, which is a way of representing the internal state of a neural net. What is this doing to me? This is really odd. And my computer is running really slowly, which makes me suspicious that something untoward is happening here. But let's try this again. And you know what? I mean, when in doubt, use one's own tools. So let me go ahead and just signing into the cloud for me there. Let me go ahead and try and use system processes, system process data. And let's see what I can do here. And let's find out. Let's do a sort by on that. Let's just do a sort by memory usage. So sort by in there, let's say memory. See if that works. Okay, oops, I should have done a reverse sort by, but let's go to the end here. 6 gigabytes. Mail is using 6 gigabytes. What an outrageously corpulent creature. Oh my gosh, what's the world coming to when one's mail program uses 6 gigabytes? Actually, talking of which, I can show you, but I probably can't show you this live. One of the new things is connecting live to an IMAP server, and I could actually go and start processing my mail live, but I'm not going to live that dangerously, and do that. There's limits to the limits to transparency, and processing mail I haven't even looked at is probably not a great idea here. But in any case, so I could actually, let me go ahead and look at system time. Let me sort by system time here. Just see what and I should have done a reverse on that. Well, that's interesting. Zoom, which is part of the framework that's being used to transmit this live stream, is using tons of CPU time. So it goes. Okay, question that came next. Okay, so I was just looking at net state. Oh, net state object. Here we go. That's what I want. This is a new thing that allows one to basically store recurrent states and update them. Is it possible to have a Python cell which can run Python without using the string? So let's see, what do you mean without using the string? So you can say external evaluate. If I say external evaluate Python, comma, and then I say, 34 to the power 6 or something, then that will run, that just runs Python like that. If I want to call, this is doing it as a piece of the notebook here. And you can have a big lump of Python code in here if you want to. And we do a pretty good job of converting data types. And so, for example, if you want to get an image back, you set a Python variable, you can go ask the value of that, you get the file, and you can go import that and so on. Okay, next, let's see, use cases. Okay, preliminary quantum computing stuff to play with in 11.3.1. Don't know if it'll be available there. We have been building a sort of standardized quantum computing package that's coming along very nicely, actually. I don't know exactly when it will be ready. Somebody's keen on curry. Good. Glad you like it. It's the full version of curry is it was kind of difficult to design, and the full curry allows all sorts of elaborate kinds of ways to reorder its arguments, and so on. The default, which we agonized about for a long time, is what should curry of f actually just do? And what curry of f does is it curries like that. It pulls the second argument into first place, because that's the most common thing you actually need. So if I say curry, find a derivative like this, then what it's going to do is that will be just a currying thing, which I can now apply to something like x to the sixth. And then that becomes a curried form of d that I can then apply to x to the sixth. Okay. Stylus input. We haven't done that yet. One of the things that happens is if I were to bring up, so I could deploy, oops, I don't have my iPad here. Oh well. If I were to deploy a form function. What can I show you here? Let me show you something. I'm going to, if I'm lucky, I have an iPad in my bag here. Hold on a second. This is okay. I have an iPad Mini. Let's see what happens here. All right. So what I'm going to try to show you is and I probably want to plug this in because it seems to have almost no power. Okay, what I'm going to show you, let me set up my camera here. And something, if you haven't seen it, definitely worth seeing. Set up the camera. And I could just use dynamic of current image, but let me use just a standard camera here. There we go. Oh, I got to use the white pad of paper behind the iPad trick to not have it wash out like that. Let's see. That's a bit better. Okay, let me make it a little bigger on the screen, and then I will show you what I was trying to show you. Okay, so there's my iPad. Come on, focus, camera, focus. How do you do that? Do I press a button here on the camera? What does that do? Does that focus it? Well, somewhat magnificent. Okay, this is Wolfram Player, and it plays notebooks that it can find in the cloud. So if I go here, this is actually running locally on the iPad. This is running the Wolfram engine locally on the iPad. So for example, here's a manipulate, so I can go and scroll through this. Here's a manipulate, and I can go and do computations with the manipulate directly on the iPad. So this is pretty cool. And basically what's happening here is you're transferring these notebooks. Well, you can transfer them in many different ways. You can get them from the cloud, or if you get sent a notebook in email, you can then just immediately open it in this player app, and that's pretty nice. You can also, of course, go to no, I don't want to go there. I want to go there. You can also just go directly to the Wolfram Cloud, and great, it doesn't like my email address, or it doesn't like my login. Oh well, so it goes. You can go directly to the Cloud app, and the Cloud app allows all kinds of input that beyond just textual input. And one of the things we're looking at is allowing stylus input for the Cloud app. So then you will be able to just enter things with the stylus that way. You can do the note taking, by the way, in the Cloud app just fine on an iPad. Let's see, automatically timestamped entries. Actually, you can get automatically timestamped entries. I never do this, but for example, you can get here, if I go to the cell menu, I can go to notebook history, and I can see the history of everything I typed into the notebook, and you can actually get that in computable form. We're actually going to be adding some more computability to this. And there is a way to set every input line to give a timestamp. I have not done that in probably 28 years, but I'm pretty sure that if I go to this option inspector, I can find a thing that shows, let's see, cell labels, cell frame options. I'm sure it's in cell labels. I don't immediately know how to do this, but it's somewhere in one of these ridiculously large number of options. There is a way to have it label every I'm sorry, I'm not going to be able to find this. I wonder whether it's what it's called. Maybe it's called timestamp or something. Anyway, there's a way to label every cell with its time. Positions of words in a word cloud. Well, I think you can do some of that. I'm not sure how well you can do it. Easier to find items when they're more or less alphabetical. It's an interesting idea. It's an interesting idea. We should look at that. Can I use minimize or maximize with a GPU and a new option? Well, let's see. We should be making serious use of GPUs through the underlying libraries that we're using. Certainly in neural net stuff, which is obviously doing minimization internally, we are absolutely using the latest GPU technology that's supported through the various libraries and hardware systems and the Intel DNN system, I believe we've recently started using. Question here is there automatic conversion from Python pandas data frames to data sets? I'm not sure about that. It's a reasonable thing to ask. I mean, I think data sets can have a lot more in them, but going certainly that way should work. Okay, somebody is suggesting that I look at cell tags. I'm just to see whether I can actually do this, because I really don't think I've looked at it in some ridiculous amount of time. But let's take a look. Show cell tags. Well, fine, but what? Edit cell tag. Yeah, there's some way of telling it to show cell tags and then to make those cell tags be timestamps. Okay, well, I think I'm almost going to have to wrap up here, but if there are any final questions, I can try and address those. I think I've gone through a decent number of things that are new in. Oh, I didn't show you this whole new documentation framework. This is a documentation framework that documents things that are not just input-output kinds of things. So it documents things that involve perhaps going to external programs and so on. So it's a new framework for documentation that we've introduced, and we have lots of examples of that now for doing all kinds of things. Let me see. Yeah, in terms of math, those interested in that, I think this is somewhat more technical, but we have a nice new function that does asymptotic analysis. That's kind of a big deal from a mathy point of view, that we're able to do. Here's a differential equation that has a small parameter in it, and we're able to do these asymptotic expansions. So if I try to do a power series expansion, we just get a bunch of zeros probably here. But this is now an asymptotic expansion, which has traditionally been kind of something of a black art in mathematical physics. But now finally we've been able to automate this, and we've got functions that do it. We could also do things like, if you're doing computational complexity theory, for example, you might want to say, is n factorial asymptotically less than n to the n. Okay, and I think I have to say n goes to infinity here. And it says true. And let's try, just for fun, because I don't know the answer, is n factorial to the n is presumably not asymptotically less. But n factorial squared, is also not asymptotically less. Wow. Is n factorial to like the 1.1 asymptotically less? I learned something here. Let's try 1 plus 1 over n. Up. Wrong syntax. That's still asymptotically less. I wonder if I go 1 plus 1 over log n. Interesting. Okay. Well, anyway, maybe if that's decreasing at all, it will be asymptotically less. But so those are tricky sort of fine calculations of working out growth rates, orders of growth, and so on. and making hierarchies of orders of growth highly relevant for a bunch of things in number theory and in computational complexity theory. We've now automated those things. I think that's about it. I'm sure I've forgotten some very important things, and the teams that work on all these things are always proud of what they've done, and it's I like to be able to show off a lot of what's there, but I'm probably forgetting some important things. But I think that's probably about it. I did just mention workflows. I'm being reminded about mentioning workflows. I did mention those. Oh, this is, I mean, for those who are really aficionados, this is important. This entity prefetch function, which sounds like it's kind of a trivial thing, is actually really important for desktop usage. Because if I say something like tungsten density, okay, that will query our knowledge base and it will find the density of tungsten. But what will have happened when I ask for the density of tungsten, is it will have almost certainly prefetched the densities of every chemical element. So if I say chemical elements here, so it won't have to go, let's see, if I just say density here, is this going to work? Yeah, okay. So that came back instantaneously. It didn't have to query the knowledge base again to go find any of those because it had prefetched these, because it is calculating, it is guessing that if I ask for the density of one element, I'm likely to want to ask for the densities of other elements. And so it will do that. That was why I was a little surprised for people who were here a lot earlier that interpreter is also doing this kind of prefetch mechanism. But I think that the sizes of the towns that we had to use were small enough that it would have had to prefetch 100,000 towns to get to the point where it was doing that. But it's got a bunch of algorithms for figuring out what are clusters of entities and clusters of properties that tend to be requested together. And that's something that will make a lot of things a lot faster. Let's see. Once the compiler rewrite gets closer to done, the compile functions will the compile functions be more expansive in the set of functions they can actually compile? Absolutely. We will be able to compile the whole language, basically. And using all kinds of callback mechanisms into the from a runtime library into the core engine. But basically, what will be done, what is being done, is sort of a complete type analysis. And that's the big benefit of having a symbolic language, is that you can actually do sophisticated type analysis directly using the language itself. And that's what's happening. And it's going to be really cool. And you're going to be able to get things like standalone executables. If you're not using too much of the, you'll be able to get chunks of standalone executable that you can run and all that kind of thing. I should comment, when you're doing neural nets right now, you can already get the material to make a standalone executable. Yes, so, oh, somebody is giving me the proof of what I was talking about n factorial and n to the n. Thank you. That's you. That looks right. Okay. Well, thanks a lot for joining us. Have fun with version 11.3. If you want to just play with it, go to the cloud and just start playing with the cloud, with the version in the cloud. Or download if you have access to the desktop version, download that, or by all means buy a desktop version and then you can use it to your heart's content. Oh, somebody is asking, somebody is saying, can you please help me with a Python program for a class? No, I don't know anything about it. The person who developed Python, I think, knew our language before he started designing Python. Knew the version 1 of our language. So I suspect there are some similarities there, but beyond that, I know very little. Let's see, somebody is asking about RDF and Sparkle. We actually have been working on a bunch of things to do with RDF and Sparkle. They're not ready yet. Stay tuned, watch some of our design reviews, and you'll see what we're thinking about with RDF and Sparkle. That all has to do with these things we call entity stores. Let me not get started talking about that. That's a way of representing sort of a generalization of relational data in a symbolic fashion. But that's for another time. Okay, well, thank you all for joining me tonight, and check out some of our internal software development meetings if you're interested in seeing how we figure out all this stuff. Okay, good night. Thanks.